This is a video about how to run a paired or dependent sample t-test. The data set that we're going to be working through for this example is the Head Start Repeated Measures data set. It is a longitudinal data set that tracks kids from kindergarten through third grade as they transition out of Head Start into the public schools. Some of the data that was gathered during these kids during this time were Peabody Picture Vocabulary Test scores and Woodcock-Johnson achievement scores. Our primary concern for this analysis is we want to compare the Peabody Picture Vocabulary scores for first grade and for second grade for the same set of kids. To conduct that analysis, we are going to go to Analyze, Compare Means, Paired Sample t-test. The variables that we're going to be working from are going to be the Peabody 1, I'll find it down here eventually. Peabody 1, and the other variable we're going to be working from is Peabody 2. Those are the Peabody scores in first grade and second grade. The options for a paired sample t-test are pretty restricted. They allow us, just as with the independent sample t-test, to determine the confidence interval range that we are interested in and how we want to handle missing values. In this case, we're going to exclude all cases that are missing either of these values. We click OK, and we have our results. What we see here is that the mean VT or Peabody Picture Vocabulary score in first grade was a 73, and in second grade it rose up to an 81. This is done on the same number of kids, in this case 1,313 kids. The correlation between these scores for these two kids was 0.779, so it's a very high positive correlation. We would reject the null hypothesis of no correlation or zero correlation between these two scores, since that value right there is less than 0.05 or 0.01 or even 0.001. We come down here and we see that the mean difference in those scores was about 0.84. That is, the student in first grade, their Peabody Picture Vocabulary scores were 8.4 points lower than they were in second grade for the same group of kids. The standard deviation in that case was 10, with a standard error of the mean difference of 0.2914. So to understand what our t-value is going to be, we divide 0.842 by the standard error of 0.2914, and that gives us a ratio of 28.9, which means that our observed difference in means was almost 29 times greater than the difference that we would have expected on the average simply due to random sampling fluctuation alone. The standard error of the mean in this case is the standard deviation of the sampling distribution for this t-test. So that tells us how much fluctuation we should expect around a mean difference of 0 if we are pulling data from populations in which the null hypothesis is true. The null hypothesis in this case is that the Peabody Picture Vocabulary score, the mean for first grade, is equal to the mean for second grade. Based on a t-value of this size, we end up determining that a t-value of that size would have occurred due to random sampling fluctuation alone when the null hypothesis is actually true less than 1 time in 1,000, 0.000, doesn't mean that it would never occur, but it does mean that it would occur fewer than 1 time in 1,000. So assuming that our alpha level that we are using is 0.05, or even if it's 0.01, we would reject the null hypothesis that the population means at time 1 and time 2 were equivalent.